I'll maybe be a little bit less definitive here and tell you how I approach a data visualization story. And let me move on to say a little bit about me. So as previously announced, I'm a science data and investigative reporter. I'm based in San Francisco. Over the years, and it is now many years, I've been in journalism more than 3 decades. I have worked for a number of different publications. Some of those are publications aimed at professional scientists. I work for Nature and Science. I think we have somebody from the Nature Publishing Group on this call at the moment, who's a former colleague of mine. I also teach, actually, let me finish up there. I work as well for New Scientist magazine, which is, I guess, the UK's leading popular science magazine. And for the past 7 years through to this summer, I was on the science desk at BuzzFeed News. And increasingly, during my time at BuzzFeed, I was doing a lot of data analysis and visualization to find and tell the stories I was writing. And I'll talk about one in particular, but also give you some little views of other visualizations from some of my BuzzFeed News stories in the next few minutes. I also teach. So I teach at the Berkeley AMI, which is hosting this event. I teach also data visualization in the UC Berkeley Graduate School of Journalism, that's the J School. And I teach investigative reporting in the UC Santa Cruz Science Communication Program. And way before all of this, I was a scientist. I did a PhD in animal behavior, and that's sort of coming at everything from a sort of behavioral sciences background does influence a little bit the way I think about how visualizations should work, and we'll come on to talk about some of that. So I'm going to talk in particular about this story, which was published by BuzzFeed News in late 2018. And it was an attempt to explain how, I guess, the increasingly severe fire seasons that have hit the state of California, where I live, why that was happening. So as a journalist who makes charts and maps to find and tell stories, I typically will start with questions I want to ask of the data, or a clear idea of what I'm trying to show based on, as a journalist, my prior interviews, my background reading of the scientific literature, and so on. And as I said, I come at this from the point of view of thinking about what information am I trying to convey, and then designing in a way that the human brain and our visual system will be hopefully optimized to understand. So for this story, experts in fire ecology have been telling me that 2 of the important factors, well, one you won't be surprised to learn is climate change, but the other one was population growth, and particularly population growth into what's called the wildland-urban interface, had been very important in driving fires in California and really creating the firestorm that was gripping the state. So my challenge here was to find a chart form that would tell this story. And I'll tell you first about the data I was working with. So this is the current view of this data, but it was historical data on fire perimeters. So that's the shape that got burned in wildfires, maintained by the California Department of Forestry and Fire Protection, otherwise known as CAL FIRE. Now, that data includes information on the source of the ignition in the first place, and also the area burned for each fire over many decades. In fact, it goes back 100 years or more. But CAL FIRE scientists had told me that they were confident really only in the completeness and the accuracy of the data from about 1950 onwards. So that was what I started with. And this is the initial chart that I came up with. So the human brain can't extract much meaning from a sprawling table of data, but it's very good at extracting meaning from visual patterns. Now, my goal for this story was to put all of those fires since 1950 onto the same chart and to use that to reveal at a glance how the seasonality of those fires and how the size of individual fires had changed over the years. I also wanted to look at how this varied for fires started naturally. In California, that means from lightning strikes, and those that are started by people and their infrastructure. And as you may know, power lines are an important source of fires in the state of California. So that would come under human ignited or human infrastructure ignited fires. So I decided, as I often do, to approach this story in a couple of steps using the same chart form. Now, I like to do this. Once you've introduced your audience to a graphic, using variants of it to explore different facets of the story can make the key messages easier to process than if you're constantly giving them a new chart type with every bit of information. Now, rather than thinking in terms of finished charts, like a scatter plot or a bar chart, I think in terms of starting off in terms of the variables that will capture the story in the data. And I think of how they can be visually encoded on a chart. Now, with this chart, I wanted to show how large fires had become more common in recent years, but also how the fire season, which was once fairly tightly constrained into the summer and fall, had expanded over the years. And this is the approach I came up with. So basically, I plotted years on the vertical or y-axis of this chart. And then for each year on the horizontal or x-axis, I plotted a timeline with all the days across the year. Now, along the timeline for that year, I then plotted a partially transparent circle for each fire in the data, scaled those circles by the total area burned, and positioned them along that axis according to what CAL FIRE called the alarm date, which was when it started responding to each incident. Now, you'll see as well, I've made some choices in color. I chose orange on a dark background to evoke fire. I mean, I think if you can tap into things that are evocative of what the data actually is representing, that is very helpful. And I knew that the photographs that would run with this story would likely have that color palette involved as well. But looking at the information I was trying to convey, hopefully the preponderance of large fires, large circles near the bottom of the chart stands out fairly quickly to you. But if you sort of maybe defocus a little bit from the details and look at the sort of overall shape of the chart and the total amount of orange there, I think we can get the idea that the beginning of the fire season seems to have crept earlier in the year over time, and also that we see some really big fires late in the year as well. That one is the Thomas fire, if you can see my cursor over it, which burned near Santa Barbara over Christmas, New Year in 2017. So next, I wanted to bring in those sources of ignition and creating 3 views of the data. So same chart form, but 3 views. One for natural fires started by lightning, one for fires started by people and their infrastructure, and one for where the initial cause was unknown. So for the colors here, I needed two distinct colors. I went for lavender and yellow. They are very contrasting colors at opposite sides of what's called the color wheel for the natural and human caused fires respectively. And I used a neutral white for the unknowns. And to make these charts, it was simply a case of adjusting the opacity to 0 for the fires I didn't want to show in any view, and then changing the color palette for the others. Having made those 3 views, I then animated them into a GIF or GIF, depending on your preference, to animate between those views. And I hope what this gets across is that we get like a pure signal of climate change for the natural fires, where we're getting more bigger fires because it's getting drier and warmer over the years. But what really stands out to me is the preponderance of these human-caused fires, and indeed how they seem to have really spread across the whole year as we go through time here. So that was my basic story, but I wanted to do a little bit more with it as well, and specifically to put it in to a national context here. So to do that, I was inspired by this paper, which was published in the journal Proceedings of the National Academy of Sciences in 2017, indeed by some of the sources I'd been speaking to for my reporting. And I worked with an updated version of the data they used, which is from the US Forest Service, and the data covered fires for what I used from 1992 to 2015. Now, this was the map that they published in their paper, and you can see looking at that California over here looks more like the west of the United States in the percentage of fires that are ignited by people in their infrastructure than the rest of the West, in particular the Mountain West. So you see they've done number of fires and they've done percentage of human ignitions. Now, this is what I actually published in my story. It's based on the same data set, but with some subtle but important changes to fit with my visual story. First, I'm using a simple yellow through white to lavender diverging color palette to fit with the colors used in the earlier GIF. And rather than scaling the circles in the grid I've imposed over this map by the number of fires in that each grid cell, I scaled them by the total area burned. Now, this gave continuity with the visual encodings I'd used on the earlier chart. The colors and the scaling of circles similarly represented the source of ignition and the area burned. Now, this is, I think, an important point. Continuity in visual encodings of data to represent the same or similar variables helps guide your audience through a visual story. But I would avoid using the same visual encodings to represent very different variables at different steps in a narrative. It can be tempting from a design perspective to use the same colors through a piece, to have a sort of palette for a story. But your audience will likely remember what the colors in particular represented when they were first introduced, and could misread a chart or a map if you change what they represent. So when introducing new variables, I will usually go to a different color palette. So that was how that story came about and my thinking behind it, which I hope is somewhat useful to you. I just want to show other examples from my work as well. I'll also talk about the tools that I use, and then if you want to learn them, I'll give a subtle little ad to 2 courses I teach for the Berkeley AMI. So this first one we're seeing here is from a story I published at BuzzFeed News in early summer, I think, 2021, when the Delta coronavirus variant was taking hold or starting to take hold in the US. The point I was making, judging from what had happened in Europe, where it hit earlier, was that we were likely to see what I call two Americas of COVID, depending on whether or not people were vaccinated, as to how severe this virus would be. And unfortunately, partisan politics was in play here, and that was the point being made in this chart. So what I'm showing you here is that the politics are really affected at the county level, how many people were at that time fully vaccinated, which at that point meant 2 doses, right? So what we have here, it's a scatter plot. Each point is a county in the United States. And on the x-axis, I plotted the difference between the Democratic and Republican in the 2020 presidential election on the x-axis there, and then on the y-axis we have the percentage of people particularly vaccinated. And while there's a considerable spread in the data, there is actually a strong correlation with the most strongly Republican counties having much lower rates of vaccination. I'm rather sorry to say that my story proved very prescient of what actually happened, because a lot of people. Okay, so that was one story. This is something from late 2021, looking again at my state. This is a story that looked at how in California, climate change is both going to give us more severe and extensive droughts, but also deluges as well. So as we go to a sort of flashier system of precipitation in the state with less snow and more heavy rainfall, but also long droughts and severe droughts. So this was from the drought part of that story. On the top chart, it's a line chart. I'm showing an overall measure of drought severity and extent. And you'll see I put a little reference dotted line to make the point that in summer 21, the drought got nearly as severe as the most severe part of the multi-year drought that California was hit with and ended around 2017. And then the bottom chart provides a bit more detail. It's a stacked area chart, and it shows the proportion of the state in different stages of drought, with the colors getting more intense red from a sort of yellow, orange, red palette for the more extreme stages of drought. Last thing I'm going to show you is actually an animation. So it's a video which is on YouTube, which I'll start to play. Hopefully that will kick in and we'll start to see what's going on. So this is a visualization of the record Atlantic hurricane season of 2020, when there were more named storms than we've ever seen before. I am animating the data over time with daily frames, and you can see that I'm plotting the paths of these storms. The lines get more opaque the stronger the maximum wind. So you kind of see the storms rise and then dissipate somewhat. And I add the name when the storm becomes a named tropical. So this is from the National Oceanic and Atmospheric Administration. And I'll just let it run on into September before I go to talk about the tools that I use to make these, because you can see it's around September, things start to really kick off. And at one point, I think we have, there we go, 5 storms on the go, all at one time. So to move on, I'm just going to finish up by talking a little bit about the tools that I use. So everything you've seen there, I've told you a little bit about the thinking about it, but how it's actually done. I work in using R, which is a programming language used for data analysis, statistical computing, and graphics. Just about anything you want to do with data can be done with R. And all of those visualizations I showed you were made in R. In particular, I rely very heavily on a group of packages, and packages are collections of code for particular purposes, but a collection of packages called the tidyverse in R. ggplot2 is the main charting package that I use there. Now, if you want to learn these tools, I have a BAMI course, a Berkeley Advanced Media Institute course, which you can take if you wish. That is, you can find it on the website, but there's that course. If you're not at the stage where you think you want to learn to work with data through code, you may want to try out the other course I teach for the Berkeley AMA, which is called Data Visualization for Storytellers. It goes through the basic principles of visualization, and some of that process I've just talked about, but doesn't use any code. It uses point and click tools like Tableau Public and Data Wrapper for visualization.